In this video, we're going to start talking about our exponent rules. So these are all things we learned in Algebra 1. We are going to take them and kind of put them to the next level here at the start of this chapter in Algebra 2. So first off, there's a lot of letters and examples here. It might get a little overwhelming, so I hope that the examples right next to the letters help things make sense. It says let A and B be real numbers and M and N be integers. Basically, A or B could be any number in existence, does not really matter. As long as there's no I, then we don't have to do anything funny. And then M and N have to be integers for this to make our life work nicely. So first we have the product of powers. Remembering that product just means multiply, and a power is just a number that has an exponent with it. So in this first one, if we are multiplying two numbers together that have the same base, in this case A, all you have to do is add their exponents together. That'll give you a new exponent, a new power. So in the example, 3 squared times 3 to the 4th is the same thing as 3 to the 6th, because 3 squared was 3 times 3, 3 to the 4th was 3 times 3 times 3 times 3, total of 6 of them. Now the thing that we're going to have to do in this chapter when we see these things is you're going to have to multiply that number out all the way, okay? There's going to be parts of this where you have to do this without a calculator, and I'll talk about that more during class. The next property is the power of a power property. So if you have a power raised to another exponent, you are going to multiply those exponents together. Okay, so in this example here, we have 3 squared to the 4th. That just meant we have 1, 2, 3, 4 of those 3 squareds being multiplied together. Now you're just utilizing the product of powers property essentially. And you're going to add all 4 of those 2's together to get 8. And then again, now we have 3 to the 8. Wonderful. You'd have to multiply it out to get this big number of 6,561. Next one is power of a product. If you have a set of parentheses with an exponent, you are going to have each multiplied factor in that parentheses with that exponent. Let me say that again. Each factor that's being multiplied in the parentheses gets that exponent. There's no addition sign happening in here. If there was an addition sign, we'd have to worry about some sort of distribution and like FOIL type process. But this is A times B many, many times. So like the example here, 6 times 4 cubed is 6 times 4 times 6 times 4 times 6 times 4, which you could also write as 6 times 6 times 6 times 4 times 4 times 4 if you want to just reorganize to get your 6 cubed times your 4 cubed. Now, in practice, you're not going to use this property for numbers, more so you'll use it for variables, because here you easily could have just said, well, 6 times 4 is 24, 24 cubed, and then do 24 times 24 times 24. That's the exact same process. Next up is the quotient of powers property. This is one that I very much like using because it makes problems simpler if you can use the property. If you can't use this property, you will have to deal with larger numbers frequently. So if you are dividing two powers that have the same base, assuming the base is not 0 because you can't divide by 0. Technically, there's some other fun behind-the-scenes things there, but if you are dividing powers with the same base, you just subtract the exponents. So how we show this in Algebra 1, without technically using that rule, is like in this example, 6 to the 5th over 6 squared. There's 5 6's on top, 2 on bottom, and we just came through and say this one cancels that one, this one cancels that one, right? I have an extra 6 here. I should fix that. I'll have that fixed in your notes. But you are left with 3 6's on top. That's 6 cubed. You are left with no 6's on bottom. But what we were doing was a division process. That's where this 1 comes from, because there's nothing left over. After dividing something, we had to have something on the bottom. It was a 1, because you could have written this as 6 times 6 times 1. So then 6 cubed over 1 is 6 cubed is 216. So again, apologize for that typo. It'll be fixed in your notes. Next one is power of a quotient property. This is basically the same thing as the power of a product property. Okay, instead of being the factors in there, it's the things that are being divided. Again, B can't be 0. Otherwise, same rule. The 0 exponent property is anything to the 0 is 1, with the exception of 0 to the 0. That's a fun rabbit hole if you ever want to try to go down that. Does not matter what the base is. If it's some number raised to the 0, the answer is 1. And then the negative exponent property is the least intuitive of the exponent properties. It says if you have a base a to the negative m, that's the same thing as 1 over a to the positive m. Or if I had a to the positive m, I could say that's 1 over a to the negative m. That's the hardest one to wrap our head around. So here's an explanation of those last two. I have a series of exponents here. How we're getting from the one line to the next is dividing by 3. 3 cubed divided by 3 is 3 squared. I hope we can all agree 27 divided by 3 is 9. Wow, I got multiple typos today. I got to get all these things fixed. That should be a 3 right there. Because when I divide by 3 again, I'm going to get 3. Got happy with all my typing and made some mistakes. So now when I divide by 3 again, I'm going to end up at my 3 to the 0th, but 3 divided by 3 is 1. And I'm going to continue that pattern. 1 divided by 3 is 1/3. 1/3 divided by 3 is 1/9. This 1/3 I could write as 1 over 3 to the first. This 1/9 I could write as 1 over 3 squared. Okay, so that negative exponent property just says if you have a negative exponent, think of it in terms of this is on the top or the bottom of the fraction, switch it to the other side, and change the negative to a positive. Okay, those are all of the rules in a very short, sweet, fast video. Please ask questions if and when you have them. Otherwise, you have this table here to look back throughout the entire chapter. Have a great day, everybody.